Good evening, my name is Antoine Scott, and I'm the co-curator of the forthcoming exhibition, Emergence, a Genealogy, which seeks to explore the complex yet fascinating community of bioart and artists that intersect with the emerging understandings of synthetic biology, its tools, and its practices. Emergence is currently one of dozens of exhibitions being supported by the Pacific Standard Time Initiative of the Getty. I'm pleased to introduce this evening's event, 1000 Days, which serves as a programmatic expression of ongoing research for our exhibition.
I'm really excited to be having this conversation and meeting you in person, Drew and Jennifer. This discussion could be as vast as synthetic biology itself. So let's jump straight in. So with biotechnology, I think it can be very vague. And as the general public, we see the end products and it's really amazing and wow, but actually the intricacies of what goes on behind that and the prelude to that is always very mysterious. So I was wondering if you could demystify some of the work that led to Pure, which is an artificial model system with the potential to remake 36 life essential functions and the prologue to the 1000 days concept.
I actually kind of want to just attempt this by starting with the word synthesis. And what does that mean in its root? It's a putting together, composition, and we're familiar with synthesis in the world of art and in music and in everything in which we have agency. For the history of life synthesizes itself, but our relationship to it is it happens to us. And so when we take this perspective of intentionality and the responsibility that comes along with it, and we're putting together life, is it sublime? Is it beautiful? Is it scary? It's probably mostly scary or just doesn't work, but sometimes it's sublime and beautiful. And so in the root of what's happening, I hope you might see everyone a connection between the making of things, whether it be art or living systems. Since you asked specifically about Pure,
Yes.
in this environment, I want to acknowledge where Pure comes from. So this is a research innovation about 20 years old from colleagues in Japan. And it stands for protein production using recombinant elements. What they figured out how to do was purify from existing life forms all the biomolecules needed to, when you mix those molecules back up in a tube and then add whatever DNA you want to the tube, the message encoded in that DNA will be made by the Pure system. And it's called Pure because they figured out exactly what molecules are needed to do that bottom-up reconstitution of, in a tube you could mix up from scratch, take any DNA and have that DNA make your favorite molecule. And is the starting point for what we're attempting over the next 1,000 days by asking the question, could pure make pure? Could pure remake itself? If we added the DNA encoding the molecules that make pure to the tube, do we get more of that? And that would be the beginning of an autocatalytic cycle.
So it would be a replication process.
That's right. A
I
growth
see.
a growth process.
A growth process.
A synthetic growth process for which every component is known to us. We might not perfectly understand everything, but at least we know who we're inviting to the party. The technical innovation we've realized is we've learned how to ask and answer the question, can pure make itself? And we know the answer is no, but now we also know how to debug, like why not? And what do we need to add in addition to the mixture to make it turn over? That's why we talk about it in the context of 1,000 days. We started this work 6, 7, 8 years ago, and it's just total ambiguity. And it's the creative work of the graduate students, the PhD students, and their superpowers of navigating this ambiguity who have gotten us now to what we think of as a starting line. Like, we know how to coordinate the work. We know how to debug the puzzles. And so we're ready to go. And when we think about how much work is ahead of us, feels like it's about 1,000 days of work.
So Jennifer, your work as a bioartist and director of the Incubator Hybrid Laboratory, it challenges synthetic biology and its applications. Where do you think art is most pertinent in this concept? Because this is an incredible technological development. So in terms of bringing those two worlds together, where do you see art?
So I'm a bioartist. I work in art and biotechnology. I have no scientific training. I read a lot of scientific papers, and I sort of like adopt scientists, and I get them to teach me what they know how to do. And so for many years, I would just travel the world, and I would go into labs, and I would try what they did, and then I would make some art projects out of that. And I found that I was kind of a disruptor, but also a friend and a provocateur. And often at the end of those residencies, the scientists would say to me, you know, I got a lot more out of that than I thought I would. I learned something new about my practice. So the reason why I think I'm here, and maybe what I have to offer, what you're talking about, is that over the years, science itself has become my topic of interrogation, and not just big capital S science, but all the little minutiae, like the bureaucratic processes, the hiring processes, the methodologies that go into making science. So I suspect I'm here to sort of talk maybe with you a little bit about some of the processes that are involved in these large collaborative projects that seem to involve all different types of scientists, but maybe also thinkers of different kinds. The 1,000 Days prospect is also like an interesting short-term turnaround reality TV maybe proposition. Like, you know, people like, what can I do in a year? Or so I'm just here to really have that conversation with you. I'd love to learn more and ask questions more about how your lab and this project, because it's not just your lab, functions.
Yeah, thank you. That's a great answer. Reflecting on the needs of humanity, what is the goal, would you say, for actually creating a cell from scratch? What do you think humanity can do with that?
We live in a life well, in a basin of attraction which holds the forms of life that we are and that we're familiar with. And we're in the bottom of the well because we're trapped. We're constrained by lineage, our parents, the life that came before us. We're constrained by the requirement of, if life's going to continue, it has to reproduce. We're thirdly constrained by, if the environment is changing in our well, life better be able to change too. And so being within a well is wondrous and sacred and safe and protected, but it's also like we're trapped down here. And the possibility of constructing life is like climbing and clawing and scooching up to the top of the well, to the lip of the well. And now what's up there? I don't know. But what I do know is possibility is up there. because it lifts us up out of the constraints, these three constraints of lineage, requirement of reproduce, and requirement of evolve. I give you the utilitarian dream, but I don't like that. That's like bonus.
Jennifer, I think from your perspective, actually, as a bioartist, your interest in a concept like this, how would you approach it? What would your perspective be?
Your metaphor of a well, it feels a little religious. It feels like this really progressive, reaching towards transcendent goal. And I think that could be like a useful or motivational metaphor, but I'm not sure it's accurate. So I'm still just reveling in this story of us in a biological well, aiming for the future. I get a lot of questions from people who are asking me about whether biotechnology is incredibly unnatural, or, and then the implication of that is like evil or harmful, and all of those things. And I often argue that actually it's quite the opposite. It's incredibly natural. If you look from an ecological standpoint, organisms sort of consume resources, they excrete resources, they produce waste. Some other organism eats the waste, right? And then through doing that, they build like domiciles for themselves, or they gain more energy, or they transform in different ways. And so I actually, when I hear this story, I don't think that it's unnatural, and I love your description of your engineering description of constructing versus sort of like a Genesis story, right? Like, so you are constructing these molecules together. But I think that if you take into its logical extent, what we're doing in the lab today is natural and is just like this ecological thing that organisms tend to do, is to consume all of the resources around them until there's nothing left, and then they die. And so that's sort of the way that I read what you're saying, is that that we are doing in the lab, that we're exploring the parameters of what is possible in the lab. And one of the sort of ultimate goals might be making new life rather than reproducing existing life.
So my moral compass is am I contributing to improbability? By my decision, am I making things more improbable? Then directly or indirectly, I am contributing to the good. And if I am destroying or reducing this improbability, then that's a bad thing to do. And so by this frame, I find myself through my actions, I don't see any distinction between human or nature at all. I'm just part of life, and I am realizing and contributing to life by this type of action. And getting to the capacity of being able to construct life from scratch without these constraints is like the ultimate platform or starting point for producing improbability. And so I'm attracted to it because it feels like the fundamental good that is at the core of my moral compass. Does it mean that everything that will happen with this will be? No way.
I'm feeling 95% of what you're saying.
What's the 5%?
Yeah, let's talk about the 5%.
The 5% is the part where you say, and that's good.
Yeah.
Right? Like contributing to biodiversity, and I describe it, I'm interested in contributing or being part of the unfurling of the universe, which I think is a very similar sensation that you're talking about. There's like an entropy, and the unfurling of the universe for me is neither good nor bad, and the outcomes are not good or bad, but I enjoy the sensation of participating in that unfurling. It's just the part where you say, and that's good. But that's okay. We can be different.
So we don't know if it's good, and that's the point of contention, because it's all about relationship. It sounds like we can create these synthetic biological systems that fit into our living systems as long as it's all in harmony, then that would be good. But there's the improbability and unpredictability.
Harmony is impossible. That's not going to happen either, right? Like if everything goes well, there's always going to be challenges or suffering and the end of life, right? That's also part of the natural world. I think I'm just really puzzled that I'm sitting next to a world-renowned scientist who is emphasizing like this goodness, when I would expect that from me as the artist. So it's just a really interesting inversion of the descriptions of our disciplines.
So what needs to be built in when we're building to kind of control for some of that?
So that's a great question. We don't know. And so we're figuring it out as we go along, and we would take upgrades happily. We learn as much as we can from what we can study. So the Apollo program that got a person to the moon and back a couple times, that's interesting. But note that it didn't routinize bringing people to the moon and back. It was a moonshot project and no infrastructure built along with it, right? Like we just did it and then we stopped doing it. That's one choice we're making, and so that changes how we go about the work. We might not be the first to do it, but we're doing it in a way that allows us to continue to do it on a sustained basis. Another thing that's a choice we've made is to, you could go after this and said, I've done it. Ha ha ha. Not you. Right, good luck catching up.
Competition.
Right, like good luck. Or you could say, well, no, let's climb up the well together. Leave some handholds. Sorry for the I'm going there, right? And so we've adopted the phrase, like how we organize ourselves will impact how we organize ourselves, and vice versa. We're trying to build architecture that enables community, even though the community doesn't exist in this way right now.
So I have some suggestions.
Yeah, I was going to ask Jennifer. I'm sure you have some suggestions.
So I have a laboratory research group, and we have team members from all different backgrounds. We've been thinking around the idea that biotechnology might be a technology of love. And what would it be to practice interspecies relationships in the lab with the notion of love as a motivational factor? I would like to first say that I do not mean romantic love or Hollywood love. I mean bell hooks, committed political durational commitment and inter-exchange love. And then it grew, and I got thinking about like not just the relationships we have with the organisms, but the relationships that we have with each other, right? Who is allowed in that lab? What backgrounds do they come from? What knowledge are they bringing to the table? So I have artists and scientists, but I have philosophers and I have nurses. I have people from very diverse cultural backgrounds all working in my lab. The diverse age range in my lab is from 19 to 69, I want to say. And what happens is that then we have this like chorus, this cacophony of interrogation around ideas. The outcomes and the community that we build in that space are really profound. So when I read about your work in this paper and listening to you now, I'm thinking a lot about the pandemic. And I'm thinking a lot about how in less than 1,000 days, we came up with a vaccine internationally. And on the one hand, for me, this is like one of the epitome examples of what science can do when we break down international borders, boundaries between corporations and governments and these types of things. But also, the rollout of that vaccine made visible to us the areas where we are failing, right? So there were all sorts of communities who did not feel a trusting, loving relationship with those vaccines and were unwilling to try them. And so I think that what we can learn from that and what might be really valuable for your project would be to widen the scope of who is involved in the production of this research and what are the discussions. Not just a technical discussion of how to build this cell, but the cultural discussion at the front end of the production of the cell. Thinking about what communities are going to have access to this cell, how will it benefit them, how would they like it to benefit them instead of how you think it might benefit them. I think that there's some real opportunity here to learn what we saw as the successes and failures of the pandemic and how that could transform scientific methodologies to be more inclusive and more polyphonic in the number of voices that are involved.
Scientists are taught that science is objective and it's not. I don't think we're free from bias, and our ideas are only going to be as good as the assumptions of the people involved. And you mentioned inclusivity and having a lot of diversity. So I wondered if you could sort of maybe comment on how we could redefine those disciplines and individuals that are included. So Drew, in your lab and the project that you did with Pure, where you're inviting people to partake in that, how does this actually marry up in terms of bringing those two things together?
At the end of the day, with like a lab is a relatively tiny place, and as much diversity as you might bring into it, it's always going to be selective. I would respond by sharing the following set of questions. How many people should have the option of learning to read and write? Basic primary education. Apparently the United Nations says that's a human right, so we think it's everybody.
Yeah.
And then well, how come? And it's related to your question, right? So that everybody has that optionality. How many people should have the option of learning to read and write a computer language like Python or HTML? And apparently we're trending towards everybody, because we have things like computer science for all in the US. Like let's give everybody the option of learning to become literate with respect to expressing intentions with electrical computing machine. So then the third question and last one in the series is, like, how many people should have the option of learning to read and write DNA? I'm going to say everybody. All right? And I practice that behavior within a context that's not the starting point. The starting point of the practice of reading and writing DNA goes back to, in my amateur understanding, the fear of being bad parents, captured in one form by Mary Shelley with Frankenstein, that inevitably as parents we will fail our creations or constructions sometimes, and that fear is so profound. When genetic engineering got invented 50 years ago, it came into the world with that current of fear carrying it along, and the nerds, all they could respond with was utility. We're going to cure disease, right? That's a good thing to do, right? But it just tried to counterbalance or push back fear with utility without ever really resolving the fear. So there's this coupling between fear and diversity and accessibility and optionality and citizenship. Are people going to be citizens of the bio-future? Or are they just going to be patients and consumers or subjects? Or I prefer citizens.
I think we really align in a lot of different ways, but I'm really, the thing that I offer and that my community can offer to your community is that it's not just that the people who read and write DNA should be in the room who determine how to read and write DNA going forward. You want people in the room who do not know how to do that, but have other knowledges, experiences, goals to offer your project. Yeah. And we were talking beforehand, I read a lot of scientific papers, and sometimes I understand them, but sometimes I don't. I read them like concrete poetry. It just sounds like sounds. But there's something about having those other communities and those other people in the room that might not only transform for the better, for ethics or those types of things, but also improve the research that happens in scientific labs. And that is what a lab like mine is trying to do.
Amazing.
This has been a beautiful conversation. I love the tensions and the overlap, and I hope everyone has enjoyed that discussion too. Thank you so much, Drew, and thank you, Jennifer, for being our panelists this evening.
Thank you.